So I lowered the frame rate. Maybe that will make Twitch happier. That does make Twitch a little bit happier. Alright, hopefully this will work. I wanted to up the resolution because some people have been complaining about not being able to see the screen. I wanted to make sure that the screen, the stuff was visible to everybody. There. And we'll pause this preview. Alright. So where were we? So we had something that will, in fact, generate a parse tree, and is otherwise functional. Have I made any changes since then? No diffs, not chgrlog log. So no, I haven't made any changes to do anything. Last time I spent a lot of time trying to figure out why. Oh, that reminds me. Why Compiler Explorer? Why when I put it in Compiler Explorer, it wouldn't use the distance, the cheap distance. It wouldn't use operator minus to try and compute the distance. And I basically gave up on that because, because it wouldn't work. Now, in my opinion, that means the standard library is broken. Standard difference should, in fact, if you have an operator minus for your iterators, it should use it if it's available. It shouldn't just look at the iterator category and go, well, if it's not a random access iterator, clearly I can't subtract them. It should just look to see if there is an operator minus, and if there is one, use it, because if it's not efficient, you wouldn't provide one. So that's that. So now the next thing is what are we going to do here? So I think the thing that we're going to do here is we're going to try adding assignment. Well, first we're going to say sequence equals expression semicolon followed by optionally a semicolon and another expression. Right? So a sequence is an expression followed by a semicolon followed by, optionally another sequence. That's right. So it's either an expression that, actually this is what it needs to be. Because we need basically every expression should end with a semicolon. So this makes it so that every sequence is every expression, an expression followed by a semicolon, and then possibly another sequence, which would be another expression followed by a semicolon, and so on and so forth. And so, yeah. Then we're going to add another possibility to expression. We're going to say or, and then identifier equal expression. So this is what's going to enable us to assign expressions, have assignments. Oh my. this isn't going to work because expression then might also be identifier equals. But that's okay. That's okay. Because if we have identifier equal, identifier equal, identifier equal, that's fine because we'll just use the. But then that implies that equal has a value and we won't be able to use it anywhere else. Except we will. I don't want that. So here's what we're going to have to do. We're going to have it be statement. Followed by a sequence. So a sequence is a sequence of statements. And then a statement is an expression or identifier equals expression. Right? And so, yeah. And we'll just say, we'll always say that the first production is the top level production. What are we doing here? So we're trying to modify the grammar so that we can have assign things to identifiers. And so that then later when we use them, we actually get something out. So I introduced the concept of a statement because I did not want this to have a value. I didn't want it to be an expression. Expressions are things that have values. And they have to be because they have to sort of be able to be added or subtracted from a term, right? And so they have to be something that can be added or subtracted from a term, which means they have to be a value of some kind. And so if I made this construct an expression, that would mean it implicitly had a value, which I didn't want to do. I didn't want it to have a value. So that means I needed to introduce the concept of something that doesn't have a value. So statement doesn't have a value. And a statement can be an expression, which does have a value, or it can be this thing, which doesn't have a value. Yeah. And a sequence is just a sequence of statements, which may be expressions, or they may be this assignment statement. So that turns assignment into a statement, and it's not an expression. It's a statement. Statements don't have values. Expressions do. So that should enable identifier assignment. That grammar change should enable identifier assignment. So then what do we do? So does the parse for expression change? No. Expression is what it always was. Okay? So then we have parse statement. First, sequence is going to have to refer to parse statement. So we're going to have to do statement first. Like that. So if we get to the end, if we're at the end, then we do this. Otherwise, we try parsing. Okay. Oh, actually, the other thing is we added two new lexemes. We added the equal sign and the semicolon as lexemes. And what's the purpose of the numerical literal? So remember up here where I had all of this stuff here with these different sort of atoms, these fundamental bits of the language, these lexemes. Each one of these represents what's called a lexeme. So there's three different lexemes here that all represent a number. Right? And so all of them basically a number. And then there's the identifier, and then there's an operator, and then there's parents, right? Well, if you look here, if we look at our tokens, our token types, we have the base token type. So that's the token type that everything is. And then we have unsigned integer. Oh, yes. I see. That's that. Now we go down here. So the unsigned integer is the token that's a number of some kind. So now let's see here where we look at numeric literal. So if we look at our grammar, numeric literal is a grammar thing. And you can see it right here, right? So this is where the numeric literal fits in. A factor is either an identifier or a numeric literal or a parenthesized expression. And so a numeric literal, what a numeric literal is when we parse it, in fact, we don't have a direct production for a numeric literal. We have parse factor because we're actually trying out all the different alternatives here. So we look. Are we looking at an identifier? Is the next token, the next lexeme, a identifier? And if it is, then that's the part of the grammar production that we're at right now. So we're grabbing an identifier, and we're looking at our factor, and we see it's an identifier. Okay. So then, otherwise, maybe it's not. So then down here in parse factor, we check. Okay, so it's not an identifier. Is it an unsigned integer? That's the numeric literal part right here. So if it's an unsigned integer, if it's basically just a number straight up in the code, then we look, or we create a numeric literal parser node expression part of the expression tree called numeric literal that holds the value. And then and then otherwise, if it's not that, then we look. Are we looking at an open parent? If we're looking at an open parent, then we go, okay, well, we're going to parse an entire expression, and then we're going to look to see that there's a closed parent at the end, right? And then if there is, we've done it. Otherwise, if we don't see a closed parent, something's wrong with the parse, and we have to quit. So that's what numeric literal is. Numeric literal is basically the expression tree representation. Because with this whole parsing thing, as you can, I think I had a detailed tree in the comments. We're creating this tree, right? And so these things in the tree, these are the numeric literals. Does that explain what the purpose of numeric literal is? It's kind of like the in-tree version of the unsigned integer token. Yes. Numeric literal does inherit from expression. Let me double check to make sure that I am correct about that. And I shouldn't call this expression. I should call this parse node or something, because then it gets confused with the expression production, and this expression and the expression that's listed there in the BNF are not the same thing. In fact, we're about to change it so that an expression might in fact be a list of statements. So we have binary operation is inherits from expression. Identifier inherits from expression, and numeric literal also inherits from expression right here. answer your question? And there's a nice long delay in the whole thing here. So what I will do is I will just continue on and find out by looking at the chat later whether I answered your question or not. So semicolon here. Oh, good. Semicolon here is a new thing that we've introduced, and same with the equal sign. Both of these are not things that we've cared about in the past. That means we have to have tokens for them. And so we're going to have to add these. Which, I mean, that just seems like, well, that's so simple. Why are you? But you know, you got to turn it into a token. So we got to have it in here. Like that. So now we've added two new tokens. We've added the semicolon and the equal, which means we need to have and semicolon is just a particular kind of base, and struct equals also, like, there's nothing that we need to know about the semicolon or the equal other than that they're there and that they're a semicolon or an equal. So we add them to our list of tokens here for the variant. And I'm going to, since this is starting to get too long, like I had this, I don't know whether you guys can see it, but there's this really light line here for 80 columns. And even though 80 columns is like inherited from punch cards, I still want to stay within that limit. It's kind of a little bit of discipline. You don't really want necessarily arbitrarily long lines of text running off to the side. So I think 80 columns is a fairly good limit, even if the reason why it's 80 columns and that's another number of columns is largely has to do with punch cards. The people who chose 80 columns for the size of a punch card did it for a reason. They could have made it 100-column punch cards, but they did not. So, semicolon and equal. Now here for tokenize. Here. Then we have to add else if and that's what we do. Do we even need, like, we don't have values, so we don't need two strings. We only need one string. So this one, we don't have a value underscore, right? Like that. Oh, no, sorry, we do have a value underscore here. Silly me. It's here where we don't have a value underscore, like there's no reason for the second parameter. AI to the rescue again. Oh, it does such a wonderful job. You always have to be looking at the code that it makes to make sure that it did the right thing, because it often does not. Unexpected token, and I should also, at that point, this is part of main. At this point, I should just do I don't want any of this stuff. We're just going to do there, like that. Standard exit 1. All right. And standard exit is in stdlib, so we should include If we're not including it already, we should include C standard lib, and we are not. So let's do that. There. Yeah, we want that because we need it for standard exit. Maybe after I recompile, it will realize that in fact that include is not a useless include. Okay. And then for visitor, oh, this is basically just so we need overloads for no, we want friends here. So this is the thing that prints out yeah, this is basically, we're just gonna here we still want the original value. And here we're going to do format. And then here we want like that. There we go. That's what we want here. Oh, and we want a comma. And a comma. And yes, we want token equal. And again, oh, we've got sirens. It's all lovely living next to a okay, T. Oh, yes, we want T here. And we want T here. And here we want T dot orig text, like that. There we go. All right. Now when we print out our list of tokens, the visitor will understand the two new token types that we just added and print them out. Now we don't have to add anything to any of the rest of the things because all the rest of the things just look for specific tokens and then give up. Now, if we're going to try and make it, how often do I hear the sirens? Probably about 3 or 4 times a day. So not that often, but often enough. Evaluate, we're going to get, now this is not the right thing for evaluate anymore, but that's okay. We won't worry about it. We won't worry about it too much. So we have this, we have that. Let's do we need a statement as something to evaluate. No, I don't think so. We need a statement list is what we need. And then evaluating the statement list is going to be a very interesting proposition. What was all this about? So all of this is about this now we have binary operation, public expression, we have binary operation. So there we have binary operation, identifier expression, which is just identifier, numeric literal. Let's add our new public. I have no idea what I'm going to do for statement list, so we'll just wing it. We'll just put in a bunch of stuff here. Auto const tokenizer RS. What line number? Let's look here. So where did you see auto const tokenizer? I'll search for more instances. This one is just fine. Like this one is just creating the compile time regular expression that tokenizes things. Let's look just for tokenizer. This compile time regular expressions is kind of weird. It actually generates a little program at compile time. It gets the compiler to generate a little program that does all this matching, including setting up like the names and all of that stuff. So this is basically creating a type that will tokenize things for you using the pattern up here. So let's look for other instances of tokenizer in here. Tokenize tokenizer, tokenizer RE, tokenizer adapter, tokenizer RE, matches. It basically is auto const. So those are all the places where tokenizer exists. Are you sure it was auto const tokenizer RS and not something else? This here is basically, well, let's instantiate our tokenizer regular expression and just, this basically instantiate a tokenizer from this type that we created up there and goes through each token that it generates. This one just uses this. This just uses this. This is broken actually, because it calls tokenize. It returns this, but it's a void function. It doesn't need to return it. Oh no. This is a lambda. Okay. And so then go through here through our tokens. Go through the tokens. Tokenizer. This. Our matches are basically the tokenizer running over our input stream is our list of matches. Go through our list of matches. Yeah. Okay. Yeah. That code just create that. Yeah. It creates a type. Oddly enough. Creates a type. No, it doesn't. It actually creates. So the inner workings of the way CTRE does things are very strange. It's doing some very complicated things internally, and So I guess this is actually a variable, but it's a variable that defines the function call operator. I don't. Yeah, this is right. It's the right thing. I can tell you that. This part is used all over the place. All over the place elsewhere in the code, in code that has run several times already successfully. So it's correct. Okay, let's get back to what we were doing here with the parse statement. Okay, first I was writing parse statement, but then I realized I needed to define what a statement was and what a statement list is. And in this particular case, yes. So we're going to do statement list, and then it's going to be default constructible, and yeah, we'll just have it like that. Yep, this is all correct, and these are basically just dummy sit-ins for now. And then here we're going to have private, and then we're going to have vector of expression expert pointer t's. Basically, it pointers to expressions, which expressions is the base type of my parse node. I should rename this to parse node or something, and not expression, because, as I said, it's misleading to call it that. But there's our list of statements. In fact, actually, you know something? One of the really wonderful things about using this particular tool is that you can, in fact, find out, first of all, go to declaration or usages. There. Here's where I declare what the expression. So now what we're going to do here is we're going to do rename. Oh, actually, we're going to do the refactor rename. And we're going to call it so there. It found all instances where it gets called expression, and it changed them to say parse node. So there we go. And see, parse node. Parse node. Changed them all. That's one of the nice features that CLion has. And I don't really need a statement. But what I do want is I want an assignment statement. And for an assignment statement, first of all, we'll make it explicit even though it takes 2 arguments, since that technically isn't necessary. But the left-hand side of the assignment statement is technically it's a parse node. You know something? What I'm going to say is it's a token. We'll pass in the identifier token. So where did we defined the identifier token up here? We have identifier. Okay, so we don't need anything special here. We can just say that it's identifier. Identifier const reference ID. You should know what an identifier is. It's defined up there. Oh, that's why. Tokens. There. And then there. So we need the identifier and the expression. Again, taking up too much space. And this should be back here, like that. And then we'll say like that. Yeah, that is what we want. Yep. Okay. And then, yes, we want all of these except like that. And then we also want private. That's exactly what we want for private. Yes, that is what we want. And technically, yeah, we'll just you know something? I'm going to just leave them undefined for now. Their definitions are not going to be simple. Well, statements list is going to be pretty darn simple. This one, I mean, okay, their definitions are going to be simple, but I don't want to just defer actually defining them until later. Put a semicolon there. Value part. What line number? Like 3 minutes ago, up here. Oh, this, where it says value, kind of? Is that the part you were talking about? Are you talking about, oh, this part? Oh. So one thing yes, it is a little bit odd. Technically, like, I might not even have to do this technically. I could have direct initialization. Oh, that's the other thing. This needs to be explicit. Mostly because I don't want to accidentally construct a numeric literal out of a number. I want to always be explicit about it. Gee, I used explicit for these other ones. And you know something? I'm going to drop the explicit here because it's 2 arguments. It doesn't need it. All right. So this is actually, it's not too uncommon for this kind of thing to occur. It's one of the reasons why I always name my member variables with a trailing underscore. Because then when I'm referring to them in the code, like right here, well, where does this value come from? I can tell by the underscore that it's a member variable. That's where that comes from. And so that's a naming convention that tells me that when I see something in the code that's like a member variable for the class. A lot of people use m underscore in front. I don't like that. 1, it takes more space. 2, it's a little ugly. And it like puts that information front and center, and that's not the most important part of the name of the variable. The most important part of the name of the variable is its name. And then the fact that it happens to be a member variable is like a secondary thing that's also true about it. It's a property of the variable. The most important thing is its name. And so I like having the property be a trailing thing that happens after the name of the variable. And in this particular case, the property is that it's a member variable, and I use a trailing underscore for that. And so this basically says initialize the member variable with with this argument name. And so that's the reason why it looks like that. 315 value. I hope that helped. And here, like ID.value, like I could do ID, I could store the token in here, but there's no real point in storing the whole token in here. Just store the string. Because the important thing is the name of the identifier, not you don't really need the token. The one reason to store the token is I'm probably going to end up putting things along with the token, like the line number and stuff, in the future. And then maybe I'll change this to store the token so that I can give errors about the line number, the variable the things appeared on, or something like that. I don't know. But right now, the most important thing is the name of the identifier. So I'm just storing the string. And then I get id.value out. And then expression, like expression, right? Except this I want to move. And so, in fact, I have to. I can't just do a copy. And not in 316. So, I mean, member variables you want to put in an initializer list. You don't want to initialize them in the body of the function. You want to put them in an initializer list. Partly like this might be const, right? And then once the constructor starts, this would actually be illegal code, right? Because I can't assign something to a const, right? Cannot assign to a read-only type. It's const. And so I couldn't assign to it. And so I have to say what its initial value is. And the way you say what something's initial value is this syntax right here. After the colon in the constructor, you give a list of the member variables, and then you say what are they going to be initialized to. And so that's what I'm doing here. Give a list of the member variables, in this case just one, value underscore. What's it going to be initialized to? It's going to be initialized to the argument that was passed in, value. And there we go. I could actually pass in token unsigned integer here. Yeah, I think actually what I'm going to do here is to be consistent about the way I have arguments. Is I'm not going to pass in the token, because I don't up there for the this numeric literal, and also for identifier expression. Nope, I pass. Okay. Nope, I do the same thing for that one. Okay, so we're just going to keep that consistent, even though it's inconsistent. Yeah. And again, here, I have an initializer list, right? And so I'm initializing the values of all of these member variables. ID gets this, expression gets that. It's like equal signs, except I don't want to put it in here because they might be constant or something. They should be initialized. Okay, so that's what an assignment statement looks like. Okay, parse statement. The result of statement should always be a statement list. This is ugly. Ugly. I'm tempted to do this. Just say, this function, sometime in the future, this function is going to exist. It's going to look like that. And then down here say friend. And then like that. So this function is basically now part of the interface for this class. This function is basically now part of the class, and so we'll have access to fiddle around with the statements in a statement list. There we go. And then we don't care. That's not how we want to do this. So when we're parsing our statement list, first we try to parse an expression. And we want remainder here. We're not using it. That's why it's saying that. So this is what we want here. And then if not expr, so then we try to parse it as an expression. Do we see an expression here? No. Oh, this is tricky. Hello there, Rye. I am writing a recursive descent parser in C++ that uses CTRE as its tokenizer. There is the regular expression for matching all the tokens. And yeah. And the code is reasonably well tested. I was able to, I can parse simple expressions, and now I'm trying to set it up to, I added a bunch of stuff to the productions just recently. I added these two things. And so now I'm writing a parser. I'm adding these to the parser. And I'm struggling with the fact that, I think I know what I can do here. There we go. Like that. I'm wondering if Twitch doesn't like the fact that I'm streaming in 4K. Ryan, can you see the video on Twitch? I decided to stream in 4K because some people were complaining that they couldn't see the text. I didn't want to make the text bigger. And so I'm yeah. Can anybody else who's on Twitch, is anybody else on Twitch having the video problem that McGarden is having? Okay. So why am I doing this? Because basically I want these to go away. I want these to be destroyed if the if doesn't pan out. So yes. Yep. Statements.get. No, I want statements dash greater than. I don't need .get. Okay. Now, how is it going to respond when I do this? I think it's going to not like this at all. Oh, nope. Except that's not what I want to do. I want to just have an else here. Nope, I still want an else if. What do I do? Okay, what do I do down here when I care about holds alternative? That's right. I want that. Then if start equals finished, expected. Line 379, any reason I use... So one thing is the X colon bit. It's hard to tell, but that's not my code. That's a little annotation that's put in there by the IDE. No, 2160p is 4K. That's 3840 by 2160. So it's technically 4K. What do you think 4K is? So this X colon isn't there. It's not my code. Like if I hit backspace here, what? Oh, nothing happens. But it's not there, right? Like I didn't actually try to remove it. One, I can't. Okay. One, backspace. See, backspace doesn't remove it. That's the backspace key, not the arrow key that I'm typing. And notice how it skips over both of them? That X colon isn't really there. That X colon is put there by the IDE to kind of tell you, oh, the parameter name here is X. So you're basically giving null pointer to X here. And then this reference here is to tell you that the parameter is a reference type. And so that you're basically putting in, this is a reference, will end up being a reference to this thing, which is fine. That's expected. And that's what it's there for. Null pointer is basically to go, yeah, I failed. And then finish is to say, yep, and just skip to the end. I'm done now. I'm not going to try and do anything more. That's a little bit extreme. I don't really need to do that, but that's what I'm doing. Um, oh, I just realized something. Um, yeah, this is going to be a little bit weird. Infinite loop. We're going to break out from the middle. And I'm going to have to break out from the middle. I know this, so there we go. We are going to there. So basically, we're going to create a pointer to statement, which is the statement that we're about to make. And then we're just going to say is going to be that. Okay. There's a reason why I'm doing this. It's because I have to check for the semicolon. The parse result, da 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 da. So that's not what I want here at all. And again, the error handling is going to be terrible. This goes in the else here. Okay. Now this one, if start equals finished. Oh, that's also an error. Because we basically got an identifier. Actually, this is a massive failure because a single identifier is in fact an expression. And so basically, if we see an identifier, we already tried to parse an expression and we failed. And so then we see an identifier, and then we go forward one, and it's, no, we should get here. No, we shouldn't. We should never get here. Or should we? We can get here. Yes. Oh my. There. If start not equal to finish. That's what we're going to do. Which is ugly. Because we're basically going to have lots of nested here as Sky likes to call it, the happy path. Going to have the happy path is going to be nested because the failure path can't abort early. Now maybe I could restructure this so the failure path aborts early. But right now, the failure path can't abort early. And if start is equal to finish, that's a failure path because we don't see a semicolon. And the reason why I can't fail right here because we don't see a semicolon is because there's a semicolon check here. I don't want to duplicate the semicolon check. So I want to actually do the semicolon check where it's supposed to go down here and just consolidate all the make sure not have semicolon checks all over the place in here. So if start not equal to finish. Now we try to and that's not the right thing to do. If That's correct. And this is, I think this is all correct. Let me I'm going to go through this code carefully. Actually, we should have an if not holds alternative. And then complain here. And then this is basically, this is going to be our abort early path. Because here we have a different problem than we're missing a semicolon. Here we got something where we weren't able to parse it as an expression, and we did see an identifier, but then the next token isn't an equal. And that means that this is invalid. Now, if we had more clauses here, then maybe we'd drop through. Maybe we have our print statement. There are any number of things that we could have here. But at this point in time, we know that if we saw an identifier, if we saw something, if it wasn't an expression, and then we saw an identifier, and then we didn't see an equal, that there's nothing else it could be. Once we saw the identifier, it has to be an assignment statement. And if we didn't see the equal, then it's not an assignment statement. And so it's an error. Otherwise, we do this. And so then we do expr pointer remainder, and then statement equals da. So if we didn't get the statement, then we go and then we're going to again. Okay. So by the time we get down to here, we know that we did find either that we have a valid. Oh, actually. Nope, if we got to here, then we know we found a valid assignment statement. So we can do here, we can just do we don't want to do this, so expr. Oh, nope, we did the right thing here. Actually, this is the reason why I got confused. Again, letting AI write your code. Basically, oh, nope, I already was doing that. So we can actually just we can just do this, and then have this be the else part. There we go. Okay. Again, doing extra nesting. I could have not expr here. If I did not expr, which column is this on? This is on column 77, so that's fine. If we did not expr here, then we could actually go Nope. This is what we want here. Expr is what we want here. But here, if we did not expr, we're going to do it this way. make this clearer and to do a certain thing with the happy path. So if not expr, then we have the error. Otherwise, we can just do this. Okay. Like that. There we go. And then we can do toklist t iterator equals and then here we do after equals remainder. We have to do that because remainder doesn't stay in scope. It disappears after the if statement is over, so we have to capture it. Then like that. And here we don't care. Okay, there we go. Now, if we got down here, the only way we can get down here is if we actually have a valid statement. Yeah, we have a valid statement. Then we can do statements dot and place back move statement. Yes, like this. Except we don't want to do that. First of all, what we want to do, if and if it's not a semicolon, semicolon, expected a semicolon aborting. Otherwise, what we do is we go like that. So basically, we advance past the semicolon and we say start is we set a new start. And then we do and then we have our exit condition here. And we can just say there we go. All right. There. Ha! And we don't have to, there, that's perfect. So we saw the semicolon. We basically advanced past the semicolon to the next one. We added the statement to our list. Then we go back up here. Are we at the end? And if we're at the end, then we're at the end and we're done. Otherwise, we go through and try to get another statement for our statement list. And every statement has to end in a semicolon. So there we go. Expected semicolon aborting. And we go back up here. Okay, so this is good for a same parse statement. Now, parse expression. Okay, we've got that. Assignment statement, we're parsing out the assignment statement here. Now, one of the things I could do is I could move all of this stuff here as parse assignment instead of parse expression. I could move all of this into parse assignment. It would probably make it clear. We won't do that right now, but I could. And then, yeah, I think this is right. Now, parse expression, we have to look at this. No, so that's another thing that parse expression is doing that's not quite the right thing here. There we go. Yep, we're doing the right thing here. If we don't see an operator next, that means we're done with our expression. Okay, and then we finish. So that means a semicolon, for example, will not be an operator. So that's good. And so, okay, we dealt with all the edge cases already in trying to deal with the closed parent. So this should I should compile. It should link. It should have a link failure though. What? There is. Oh, that's because that's what I'm doing here. All right. Okay, so it didn't like this. Oh, that's because I'm missing a semicolon. Well, that's the simplest problem in the world. All right, it compiled. And I'm getting linker errors. And it's because it's missing things. It's missing like various functions. It's printing out the names of the functions in a way that makes it very difficult to know what function you're talking about. Basically, it's going. There's no vtables for either statement list or assignment statement. And the reason why there are no vtables is because I haven't defined the virtual functions. The thing normally puts the vtable, the table of virtual functions, in the same place that you define the first virtual function. And so that's what it's going on about. It's going, hey, I don't see any vtables here. So we will start defining the virtual functions here. So So this is a good way to do it. Basically, the value of the statement list is the value of the last statement, which might not even have a value because it's an assignment. This one's going to be tricky because we're going to treat each statement as a print statement. And the result is just simply going to be 0. So we're just going to return 0. We aren't going to do this. What we're going to do is there an enumerate? Can I do something fancy here? This is something you can do in Python, but I do not know if it's something you can do in... you can indeed do an enumerate view. Oh, this is so ugly. I don't think I'm going to do the enumerate view. I'm just going to do this. Statement I, and then for this one, it's statement evaluate, like that. There we go. So basically, we're going to just print out the result of each statement. Every statement is a print statement. And then that means assignment statements are going to have a value, which is going to be interesting. And here, oh, this is going to be interesting. Infix string. So to infix string is going to be yeah, basically that. All right. That's the right code for that. And this is not what it's going to be exactly. So we're going to indent them all. This is not the most efficient way to do it, but it's the way I'm doing it right now. And then, yeah. So for other prefix, what do I do for them? Okay, I use parentheses. I use Lisp syntax. So we're going to do that here too. There. That's the Lispish way to say it. Prog n. Oh. There. And no semicolon. And here, we're just going to have that. All right. And then, like that. All right. So now we get to do assignment statement evaluate. Okay. So we're going to have to do something really ugly here. Really ugly. And then up here, I'm going to have a global variable. And this we're going to make, and we'll make it static. Okay. Basically, this is a terrible and ugly way to do this. And at some point in time, if I ever try to flesh this out, I will do it better. I'm having a global variable that has all of the identifiers in it. Because evaluating this is going to have a side effect, and that side effect is going to be updating this global variable with something. Parse statement. And evaluate is not going to print anything. what evaluate here is going to do is it's going to do value, and that's exactly what it's going to do. And then we're going to return the value assigned, even though actually we're going to return 0 just because. Okay. So basically what we're doing here is we're fetching, oh, nope, that's the right thing to do. All right then. Assignment to infix string, and that's exactly what we want right here. Like that. Yep. And then actually what we're going to do here is we're going to do like that. Make it look Lisp-ish, because Lisp is the prefix language. Everything in Lisp is a prefix. So there we go. Set Q. Yes. Now we have to revise one more thing in order to make this all kosher. Identifier expression now has the wrong implementation. Nope. Here we're just going to assume that any identifier that's mentioned is going to have a default value of 0. Otherwise, we're going to return the... all right. Is this better? Will it build now? All right, then. Let's run it. Let's see if it runs now. And of course, it will run because I'm not, in fact... What the heck? It's taking forever. Oh, I know why it's taking forever. I can't run it. I'm going to cmake build debug. Like that. There we go. Perfect. Okay. There's one more change we have to make in order for us to know that indeed it's kind of working. Not completely working, but at least kind of working. And that is in main here. What we should do here should do parse statement and that also means that we needed to forward declare something that we have not yet forward declared, which is this. So somewhere up here we have parse. Yep. And so we also need to say here up here, just the same as the rest of them. Like that. Now down here in main, This program is getting a little too big and unwieldy, and I should split it up into multiple files. Like that. There. Technically, I should probably use standard format for that, but we won't. I'm not going to fix it right now. All right. Expected semicolon. Ah, well, there we go. So first fix. The sample input needs a semicolon at the end. Because we now just... There. Poof. So we got the result. Statement 0, the result of statement 0, which is this statement right here. That means we need a \n here. All right. So now it parses a single statement correctly. Now let's try editing our sample input 2 to actually go like that. Aha! So, foobar equals, so it recognized this was an equal, and it did not print out the \n at the end here because I didn't put it in. Yeah, there's supposed to be a \n here. All right. So foobar equal num, semicolon. And then num blah 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 blah. So a bunch of this stuff. Expected semicolon aborting. No expression parsed. So where does it say, let's see. Oh, stupid thing. We're going to debug this, and then I'm done. I have stuff I have to go do. So this is the only place where it says that. Now, one of the things we're going to do here is we're going to change the configuration to say program arguments redirect input from sample input 2.text. So we'll see what happens when I do that. If I run it, good. Okay, so let's debug it. Okay, what does after hold here? So start, finish. Foobar statements. So there is one. Nope, there are no statements yet. So this is the first statement. And here we actually have a statement, an expression pointer t. It's an identifier expression. And that I see. It registered as an identifier expression. Because it didn't see an equal. Okay, so I have to put something special in here in identifier, where if it sees an equal when it's looking for an operator, this is getting a little ugly, honestly. If we see holds alternative tokens not operator, parent, or actually, if we get an equal, then we return, except here we actually go like that. Okay. So if we see an equal sign when we're expecting an operator, we do something special. This is basically getting uglier and uglier. I really should rethink how I do this. What happens now if we run it? Hey. Oh, wow, that's because it's missing the if. There. Okay, that's better. Result. Statement 0 result is 0. Statement 1, result is this. So let's find out. Now that we see this here, let's do this calculation. So cat parse result. No, cat sample input 2 text. Let's see if this works the way it should. Okay. Right, foobar equals 5. And then this. What's the answer here? Hey. Oh. Yes, that's right. That's an octal number in Python. So we got the correct result. We got added 5 here. That should have been then multiplied by, yep, it's the expected result. So that worked. A few other things for result here when we're printing out main result Semicolon equal program result. Oh. Come on. You know who's supposed to have focus here. There we go. All right, like that. All right, result statement 0, Okay, that works. Now, and notice how it does setQ foobar 5. So it saw that it was an assignment statement, printed it out as 1. Prints out an extra \n that it doesn't need to. I actually should check through the infix stuff to figure out, because I want to get that exactly correct. So here in assignment statement, that's right, assignment statement print shouldn't put a \n here. We don't need one. That's the job of the surrounding people to do for us. There we go, like that. And I should do an infix print or something. But as you can see, it now more or less works. It's not perfect. It's not pretty. It could be improved, but more or less works. And it does need a much more extensive test suite, and I need to try and crash the parser, partly because I can catch a bunch of edge cases that I'm now, because there's a bunch of special cases that I special cased in here. Like, oh, I should see if there's an equal sign and then do something different. That's just ugly. I should be a lot more disciplined about making these very regular and always operate the same way instead of looking for special cases. Yeah. Because every time I put a special case in here, then when I use parse expression as part of something else, that's not, maybe I use it in an if statement, for example, in which case there's going to be a closed parent there and that'll be caught properly. But there's any number of things where I use the expression someplace where it wasn't used before, and then suddenly the list of tokens that might end the expression mean something completely different. So, yeah. Like, for example, here, the equals ending the expression. Well, it's not an operator, but it still isn't something that should be ending the expression, right? This is only checking if it's an operator. Like, if it's an operator, well, the only operators that should be here are plus and minus, and they shouldn't end the expression, right? Again, special case. And so need to fix the way this whole recursive descent thing operates to remove all of these special cases, because every special case is just like a thing that needs to be modified when you change the productions. And honestly, unless you actually change what an expression is, you shouldn't ever have to go into the code for expression to add in any kind of casing for places where expression might be used. Expression just know that yeah. Anyway, that's that. I am going to end the stream now. I will off stream do a commit with a, oh heck, I'll do the commit message here. Which that's exactly what I added. I added statements and assignment. Made identifiers work. Okay. Made identifiers work with this nasty global variable. But they work. And push it. It's on GitHub. You can see where it is on GitHub. Yeah, that's today. I hope that you all have good rest of your evenings or afternoon, or go get some sleep, whatever.